Water Services Durham Plan here, 2013, Joel Richards, Chair of the Wastewater
Two main
School,
interceptors. There's the lower Tualatin and the upper Tualatin interceptor, and they meet at the influent pump station, which is that building with the teal roof down there. That's the low point of the plant. And it pumps it uphill to the headworks building, and from there most everything runs by gravity. There's one small exception, we'll talk about that. But the headworks building takes all the grit and the screenings and sends them to dumpsters, and we haul those off to a landfill. From the headworks it goes to the primary clarifiers, where sludge is settled out and it's delivered to solids handling, where it goes through thickening process. From the primary clarifiers, the flow is headed to the primary effluent pump station, and that's the other spot where flow is pumped. Most everything is downhill. We used to split the flow by weirs to 4 aeration basins, well, to 3 aeration basins, and when we added the 4th one, we just didn't quite have enough head to split them evenly. So what we did is we just raised the flow up a little bit, and then we could meter the flow to each aeration basin simultaneously. We can split it, 25% to each aeration basin, or if we want, we can say we want this aeration basin to get 5 mgd and then split the rest. From the aeration basin, it goes to the secondary clarifiers, and then from the secondary clarifiers, it goes to the tertiary clarifiers. After the flows had tertiary treatment, we add alum right between the secondaries and the tertiaries. Had to have phosphorus drop out. But after the tertiary clarifiers, it goes through CCBs, disinfection, and then we filter it. And then after it's been filtered, we dechlorinate it. And after it's been dechlorinated, we send it to the river. From the secondary clarifiers, we have a return flow that goes back to the aeration basins, and then the waste-activated sludge is headed to thickening, as well as the chemical sludge from the tertiary clarifiers. So all the sludge we remove from the liquids process goes through thickening, and then from thickening we digest the sludge. Then after the sludge has been digested, we dewater it, and then we have it in silos, and we have trucks that take it to Eastern Oregon for land application. We have a couple, during thickening and dewatering, we have 2 outputs on each of those. We have a cake or a sludge, a thickened sludge and a centrate, and then a dewatered sludge and a centrate. And both of the centrates go to a side stream treatment called Ostara, and we make a granular phosphorus component called struvite, and it comes in little capsules, and that we send off to have turned into fertilizer. And that's applied primarily to wholesale nurseries. However, if you go to Farmington Gardens, we have a product called Clean Water Grow that we're actually selling as for retail product right now.
Where do you send it out to? Local or?
The Clean Water Grow is in the Farmington Gardens nursery or for retail sale, and there's also at the Jackson Bottom Wetlands over in Hillsboro. There's you can pick some up there too. We just started doing that just a couple months ago. We've been selling it to a wholesale developer to package the product, add some magnesium, and potassium, and nitrogen and phosphorus, yeah. So anyway, potassium. That's it. So anyway, we sell that to a fertilizer manufacturer. He uses that as a major component of his fertilizer.
A little bit of pre-digestion
And then when it gets back
occurs
into
of the
the
primary
aerated
sludge
portion of the plant, it does a luxury uptake
before it
of
goes to the anaerobic
phosphorus.
digestion.
And I'm not exactly sure of the ratios, but like if it releases 4, then when it comes back around and aerated, it actually takes up like 9 or something like that. So that's why we send the thickener centrate back to aeration basin. The dewatering centrate does the same thing, and
It bypasses your clarifiers, or does it go into your clarifiers? 'Cause I can't see, I can't tell that
the
it's in line.
centrate bypasses the clarifiers.
Got it.
If we send the centrate back to the aeration basin, the dewatering centrate back to the aeration basin, it's because it helps it tries to maintain the stable load of nitrogen to the aeration basins. The bacteria can do a good job of taking up nitrogen, but if they have a big slug coming at them, they can't grab it out of the salt. But if they're used to that high level, then they can do that. Yes, sir.
So does that actually lower the amount of solids that the plant puts out?
No, it probably increases the amount of solids taken out because we actually are taking up more phosphorus when we can. Okay.
That's about everything.
The sanitary system, primary treatment.
How you doing, John?
Get down here. Fermenters at the bottom.
This looks
Or
cool.
after that, we'll go into secondary treatment. It's tertiary, where you add alum, chlorine added down, filter, dechlorinate, treated water down, solids handling, tertiary and secondary, anaerobic digester, primary sludge gets a little bit of pre-treatment before it goes into the anaerobic digester. We're always using a centrifuge to dewater. There's the Ostera system, which then makes crystal green slow-release struvite fertilizer, 528 Ostera nutrient. The Influent Pump Station Building 100, built in 2009 with the Green Building.
This is our Influent Pump Station.
Council.
We'll go take a look at it. It is, as far as I know, the only pump station that has LEEDS certification. LEEDS is Leadership in Efficient Energy Design.
Leadership in Efficient Energy Design.
And so we
LEED, there's a good
incorporated a
multiple
lot
choice
of
question.
energy-saving options in here. All of our VFDs and all of our pumps use our premium efficiency motors. And we try to do as much heating as we can. With cooling, we use our NPW, and heating, we actually recover heat from our digestion process and send the hot water down here to help heat it. So you're not really going to see the actual water coming through here, but I just wanted to let you know that this also incorporates a self-cleaning feature, as the wet wells are very narrow trench-style wet wells, and as the water comes in, the water level stays even with the flow coming in, and then every so often we actually lower the wet well levels. When that happens, it exposes the slope, and the water will take a downward bend and increase in velocity and actually scour all the debris that's in the wet wells to the back end of the wet wells where we have a large cleaning pump. So basically it sucks all that stuff up and sends it up to the headworks, and it's taken out up there. So instead of having to take our pump station offline for 2 weeks every 2 years or so, we actually just clean it on a regular basis, and it's no muss, no fuss. So,
Pump station here.
two pump stations.
There's two pump stations side by side.
Listen up, everybody. There's two smaller motors here, and then a larger motor in the back.
Smaller motor, larger motor in the back.
Downstairs and look at the pumps, and then we'll come back up. Most of the time, we only need to run one side at a time.
One side at a time.
We'll put both of them online.
Put both online.
Right now, we handle a total flow of 200 MTD.
200 MGD.
200. During the summer, it's probably around 30.
Summertime about 30
We have
MGD.
to get a little over 100 once or twice. So, yeah, winter, lots of rain.
Two motors in the front. 600 horsepower. On the other side over here, this is the variable frequency drive motors. It ramps up the pumps on the wet well depending on flow coming into the plant. So again, here's the wet well level CS. There's your flow bubbles for A and B, one side versus the other. Siemens here. Influent pump.
So pretty much everything in the plant is monitored by the PLCs, and we can run most any part of the plant through numerous terminals that we have throughout the plant.
When you say PLCs, is that different than SCADA?
Yeah, PLCs are the programmable logic controllers.
PLC programmable logic controllers.
And the SCADA terminals are actually the windows into the PLCs themselves. The SCADA terminals really don't control any part of the plant, but they do tell the PLC what to do. So we can, if we want to increase the flow to the plant, we can do that through the SCADA terminal. It goes and talks to the PLC, it says ramp pumps up. Small difference, but a little bit. A lot of times we'll need to take the SCADA system down for some maintenance.
240 force mains that go to the headworks.
During the winter, we use the larger one. During really extreme wet weather events, we can actually install that one.
Still in the influent pump station. There you go. Electrical room, and then we'll go to the valve room, and then we'll go to the headworks. Two power sources. Substation for PG&E.
No, there's no generator. That's because we do have, well, yes, we do have generators. It's not a redundant power source. We come over and we feed the switch gear here, and the entire pump station, if we wanted to, could run on one set of switch gear. We have tried to balance our loads throughout the plant so that it doesn't put a strain on it. But when we need to, we can actually, right now we have one side offline so they can be doing some maintenance on the switch gear that we have here.
Finishing up the, that's huge. There you go. How do you like that valve? On the force main. Valve control.
It doesn't, it just open closed. Open closed. Yeah.
Open and closed.
This is a 42-inch force main.
42-inch and a 54-inch force main.
So, and then we have the interconnecting valve, which is the big one, and then the two other valves which go up to the headworks.
Big valves. Okay, big valves. Valves here. The bypass on each one of these monster valves on the force mains. All automated. Don't hardly use them. So they're digesters that they took offline about, built them 10 years ago, took them offline about 8 years ago, but they're getting ready to get them.
How many turns does it take to close that big valve?
A lot.
One click of a button on SCADA.
Yeah.
So you're getting to get these back online now? That's the plan?
Yeah, that's the plan. We've got some gas valves we need to replace before we can put them back online, but they're getting set to put those on today.
There's the gas valves. Getting ready to get these digesters going today. The gas valves on them. Put them back online.
So,
there's some valves over there. It's Valve Fest.
Facilities have usually been on the east side of 85th Avenue. We built these back in 2000, ran them for a little while. We put these online because we didn't have enough detention time that if we needed to take one of those digesters offline across the street, we didn't have enough detention time. But these were so big that when we put them online, the sludge got so broken down that it wouldn't dewater very well. So we ended up mothballing these for a while. And now it's time to bring them both online. We're going to move all of our digestion over to this side of the road. So in either sometime this week or next week, we're going to pump all the digested sludge from over there into these two tanks here and bring this one online. So this little project is what's taking up all my time.
The digester gas here. Getting ready to get these digesters back going.
One of our future projects that we're building is going to be fats, oils, and greases receiving station where we can accept all of the fats, oils, and greases from the industry. We're going to break that down and we're going to feed it to our digesters. That ought to supercharge the gas production, and we'll run the gas through a cleaning system, and then we're going to run two dual, I think they're 500 kilowatt generators.
30 employees.
That doesn't include landscaping.
30 employees here. Durham.
During the night, there's like 1 or 2 nights a week that this plant is staffed by one person.
Solar panels over here that they put on site, and they they purchase the energy from this clean renewable energy source. You can see it over here. So yes, they have the solar panels through the trees here. Not cheaper than regular power.
There's
but
a
septic
control
tank.
panel that they punch in their code. It tells them who they are,
Charge here.
and then they
Discharge.
punch in what kind of truck they have, and they know how many gallons that holds, so then they can offload there. There's also a flow meter in there that records the amount of flow coming in. So we'll go on in here to the headworks.
Heading into the headworks now, coming up where those 2 force mains that we just left are now coming up here. Every 15 seconds they get switched off. Not more flow to go through, so switched it out to these new ones. Over there. The conveyor belt. Up the gun and out.
So we'll go out and take a look at the washing compound.
How many of these bar screens are there?
We got 4 of them.
4 of them.
We have 2 wide ones and 2 smaller ones. But the spacing in the bar screens is the same. It's running.
From the bar screens.
It'll
Right in
open
here.
the solenoid. It'll start flush water going down this trough.
Flush water down the trough.
These hoppers here. And there's a screw conveyor at the bottom of the hopper that actually agitates
Screw conveyor at the
screens.
bottom.
And then it runs through a compaction zone, which squeezes all the water out.
Squeezes all the water
And
out.
then the screens get dumped right into these.
Either one of those is where the screens get dumped. Good. After the bar screens, water flows over here, and this is pista grit area for grit removal. You saw where the rags go, a little bit of water, move it through, and then it gets dewatered. The screw press into the landfill.
So after the flow goes through the bar screens and all the screens have been removed, there's these channels that end up all into that corner there. But these are pista grits that allows the grit to fall out of the flow stream. And then from there we have grit pumps down below that pump them back up to a couple cyclonic degritters. And then from there that is conveyed to separate dumpsters down below. So we separate the screens and grit into different dumpsters. Prior to this, it's been remodeled about 2 years ago, and at that time we actually had the screens and the grit commingled, and the solids handling equipment really doesn't like using grit and screens together, so we were able to separate them and do a better job.
I was going to say, they don't, so they go to the landfill separately.
They go to the landfill separately.
At Tri-Cities, they have different hoppers, where I'm interning, they have different hoppers, and it all dumps into the same dump truck and goes to the landfill.
Well,
So was the reason because of...
Well, we can go down and look at the grit facility down below, but it uses a lot of screw conveyors. The
Right.
screens get wrapped around the screw conveyors, and we had plugs on them and all sorts of problems with that.
So it's the same thing, but theoretically you could just put, at the end you could put it all into one dumpster. It's not something required by the landfill.
It's not something that's required by the landfill.
Removal there. Higher density than the water, so the grit settles out. There's your big solar panels here. They put them down here and they purchase the power from it. They're going into the electrical room to get to look at the SCADA system and get the flow rate. There we are. And there's your...
So it's not a screw, well, it's a screw conveyor, but not
Right.
as extensive as this other.
Right.
Okay.
So this is our SCADA system, and right now it's looking at the influent pump station. I can see we've got 2 pumps on right now, and the flow coming in the plant is about 40 MGD.
Wow. What population is served? What's the size?
Well, Tualatin, Sherwood, Tigard, Beaverton.
Sherwood, Tigard.
Some of Hills.
All of Beaverton?
Most of Beaverton.
Most of Beaverton?
Most of
That's
Beaverton.
substantial.
Some parts of Portland, but not much. But some parts of
Is this
Portland.
the biggest
Actually, Rock.
city in Oregon?
No.
Second?
Yeah, probably. Rock Creek. Well, no, I take that back.
Has to be.
Portland's probably handles more flow. They have a combined sewer. Rock Creek is a little bit bigger than Durham is. And so that probably, well, that might put us at 3rd, but I don't know what Eugene or Corvallis. The primary clarifiers directly up
Splitter
to the
kinda
headworks building, and we'll do
Primary
away with
inflow,
the
kind of like splitter.
influence structure. It's a
After the
source of
headworks.
odors. It traps a lot of grease.
Allows it to split into one of the 4 primary clarifiers that are covered here. It's one of their next projects to figure out a better way to get it over
In order
to their primary
a good
clarifiers.
neighbor, we've covered all of our primary clarifiers.
Primary clarifiers are all
Actually
covered.
an odor source as well. And there's very little space between the surface of the water and the cover. And if you have the sweep arm that's going around, you really can't put the structure, you really can't stack the covers on top of the structure. So what we did is we put the structure on top of the clarifiers and then bolted the covers to the structure, and so it's supporting the covers above the structure, supporting above the covers instead of below it.
An in-ground odor scrubber that pulls the air
the
out
clarifiers and then runs it through a chlorine mist.
through a chlorine mist. Pulls.
So, primary clarifiers discharge